I'm an undergraduate. I'm an undergraduate student from ISER Kolkata and one of the office bearers of our club Singularity. So Singularity is our astronomy club, which is founded by the students of ISER Kolkata, and it's a space for exploration, not just to the stars above, but the ideas that brings us closer to them. Through talks, workshops, sky observation sessions, and creative collaborations, we aim to spark curiosity and deepen our collective understanding of the universe. We are extremely grateful to Hemant sir and the entire team of NASNI for this collaboration and support. We are extremely delighted to be a part of NASNI and share this platform with them. Before we dive deep into the skies in this exciting session, let me introduce a very special initiative that's going on to enrich your astronomical journey in NASNI, which is the National Astronomy Network of IAPT. NASNI is a national platform initiated by the Indian Association of Physics Teachers. It is designed to connect new sky gazers like many of you with astronomy experts, planetarium professionals, astrophysicists, and even popular public figures in sky watching. Because sky gazing becomes more meaningful when we share it with mentors who can guide us, with tools and events that inspire, and with a community that shares our excitement. NASNI is that bridge between the beginner and the expert, between curiosity and knowledge. So, dear friends, NASNI is here to guide you and grow with you. Welcome to the network. Welcome to the world of NASNI. For today's session, we have a very special guest who has joined us, Mr. Sarang Vandana. Born and brought up in Pune, Mr. Vandana studied mechanical engineering and currently works at Siemens Digital Industries Software. But beyond his profession, his passion clearly lies in the stars. He has been a life member of Jyotirvidya Parisanstha for over 12 years. India's oldest association for amateur astronomers, founded in 1944. He has also served as a member of its executive committee for many years, playing a key role in their public outreach programs and overseeing their social media presence across platforms. A passionate science communicator, Mr. Vandana believes that rational thinking, grounded in the scientific method, has a power to transform lives of students. He loves to ignite curiosity in astronomy, making it only accessible but deeply engaging for people of all ages. His interests go far beyond telescopes, too. He's an avid runner, cyclist, guitarist, and a voracious reader. And to top it all, he has also completed level B2 in Spanish, making both his orbit and his worldview refreshingly wide. As Carl Sagan once said, we are a way for the cosmos to know itself. With the right tools and the right guide, that journey becomes truly personal. So, without any further ado, please join me in warmly welcoming our chief guest to the NASNI stage. Sir, we are honored to have you with us, and the floor is all yours.
Thank you so much, Anjali, for this generous introduction. And I am very, very happy to be with you all. Thanks to IAPT and thank you, Dr. Hemant Kumar, sir, for giving me this opportunity to interact with such a diverse audience of professionals, students, and passionate stargazers like me. So really excited to start this session. Already Anjali's introduction has given you some details about my organization, the astronomy organization that I work for. That's Jyotirvidya Parisanstha. And for last 13 years, I have been working as a stargazing expert primarily at our stargazing sessions and also participating in other activities of JVP like exhibitions, study tours, basic astronomy course, etc., and also handling the social media presence of JVP. Okay, so when we discussed about this talk, so Dr. Kumar sir told me that uh, I mean, I was not sure whether, I mean, what level I should keep for this talk. So he said, you can start right from the introductory session, from the very basic session for the software and mobile apps, because there will be some beginning stargazers, some newbies who would like to have very basic fundamental information about these apps. So I'm going to start from the very basics. And if I get chance in future, I would like to have an advanced session on this also. Okay, so I'll start sharing screen. I don't have any slides, but I'll be demonstrating things on the screen itself, some websites, some software apps, and so on. Okay. Yes, so let me start with a very, very basic app. You may be aware of this or aware of such app, I mean, some other app like this. This is a GPS test. It's available. I mean, I'm showing you the web page of Google Play itself. And these are some of the screenshots from the app. Basically, this is the very first app you would like to have or you would like to open when you are at a new location. Let's say you are on vacation, or you're visiting some new place for your professional work, and there you need some information about the location, like what is the latitude and longitude and so on. So this is the app you would like to launch. So it when you launch it and when you have your GPS on, it will show you how many satellites you are connected to, the locations of those satellites. You can also see the directions, north, south, east, west, and also the local sunrise, sunset times, and many such details. Okay, so it has a dark mode also if you want to use it at night and you don't want to spoil your dark adaptation of your eyes. So a pretty self-explanatory app, but definitely you would want to try this before any other advanced app in astronomy to get your basics right. It has a map also. That map shows you your location on the. I mean, it shows it with a red dot. Okay, so let me show you some interesting screenshots. A couple of interesting screenshots. I have to run a little bit faster here because we have only 1 hour or so. Okay, so this is one of the screenshots that I grabbed from a location that I was visiting a few years back. Any guesses? Where was I when I took this screenshot? You can just unmute and say it out loud if you guess it. It shows it with the red dot, the location. Anyone?
Green, Greenwich.
London?
Yes, absolutely
Greenwich.
right. Greenwich. Yeah, that this is Royal Observatory, Greenwich.
Yeah.
And as you can see, north 51.47, that's the latitude, and we have longitude almost close to zero. But this is not an error. Actually, this point 001479, this also can be explained. And I'll share a link about this to you. This is, I mean, GPS GPS references a meridian, which is not exactly the geographic meridian, and that's why this difference. So yes, this was a screenshot taken from there, and I'll show you a few more photographs. This is, of course, the mandatory photograph of myself hanging in between neither east nor west, somewhere in between. Okay, so that's at Royal Observatory, Greenwich, and I was exactly over the meridian. So this meridian is the geographic meridian. This is not the one that GPS references. So more details on that I can share in WhatsApp group later. So something like this you can do over there. You can keep your mobile phone right on the marked meridian there and take a screenshot, right? Yes. Another screenshot from this app. So, okay, any guesses? What does this say about my location?
Is it latitude?
No.
Okay. It,
It shows you the names of the fields also. Either heading, altitude, and
okay.
there is speed also, I believe. Yeah, speed kilometer per hour. Oh, sorry. Yeah. So how do I have this speed of 859 kilometer per hour? There is only one way.
Aeroplane.
Exactly. Yeah.
Airplane.
Yeah. I was traveling in a flight, and you can also see the heading. Heading is like azimuth in astronomy. So you have exactly zero at north, then it increases eastward. So east is 90, south is 180, and I am almost uh, heading towards south. This says, even from this compass, you can see I am headed southward. So I was traveling from Pune to Delhi, and I was coming back from a trek. This was late night flight, or late evening flight rather. So it shows me the speed, it shows me the altitude, so almost a cruising altitude, and the heading or the azimuth. So this is another interesting way in which you can use this app. So you have to have a window seat for this one. So it doesn't work very well if you have an aisle seat or middle seat, right? So yeah, these
It,
were two.
sir, will it work offline also?
No, it doesn't. Yeah, wait. Yeah, yes, it does work. I mean, it does work offline also. It doesn't require internet to connect to the GPS satellites. But if you want to know more information, like some internet links and all you want to open from that app, yes, then you will require internet. But yes, for as far as GPS is concerned, latitude, longitude, and those things, yes, it works offline. In fact, that's how I was able to get it working in the flight, right? In flight, definitely my phone was on flight mode. Okay, so that was a quick introduction to GPS test. Then I have a bunch of flash demos or a very small web pages you can see. Uh, I'll open one of these web pages. These are run with Flash Player. Uh, so if you go to this about, it shows you the source of these animations. This is astro.unl.edu. That's the hyperlink from where you can download many such demos. This is a very good demo or good tool to understand the motions or understand how the sky moves because of the rotation of Earth. I mean, uh, it's actually Earth that rotates, but we feel as if the sky moves from east to west, right? Or the objects in sky. So this is a good way to understand that. So first of all, you want to set your location, or precisely the latitude and longitude. So let's click somewhere on this map, somewhere in India. Okay, if you want, you can adjust the numbers exactly. So if I put 18.5, that would be my city's longitude, Pune's longitude, 18.5 north, and roughly the longitude. So this is how the observer's view will be, and this shows you the celestial sphere. So how exactly the sky is going to rotate on a celestial, or how exactly Earth is going to rotate, and this one will show you the observer's view. I'll make some settings so that we get a very good view. We understand this better. Okay, I'll start this animation. Now see what's happening. So this is the observer, and the sky, I mean, objects in sky, especially the stars, go from east, they come up almost overhead, and then they go west. But when overhead, the stars are not exactly overhead, right? That's because, okay, I'll pause it here. Okay, this pattern, Orion the Hunter. So this is a very peculiar pattern because some of its stars lie in the northern sky, whereas some of them lie in the southern sky. So it is exactly on the celestial equator, this star pattern. But it's not exactly overhead. Why? Because I am at 18.5 degrees north latitude. So if this were exactly zero, meaning if I were standing exactly at Earth's equator, then yes, I'll see this motion exactly vertical, like stars rising exactly vertically, then passing through zenith. Zenith is the imaginary point exactly overhead an observer, and then the stars will vertically descend towards west, true west. So this is a story on exactly on equator of Earth. But I chose my location as 18.5 north, and because of that, see the how the sky is slightly tilted. Since I followed the curved surface of Earth to go northward, the sky has tilted the other way, towards the south, and that's why these movements become slightly tilted. You can also see, in fact, the angle. See, this angle between celestial equator and horizon is exactly 90 minus 18.5. Okay, That's how it is tilted. And you can also move this around and see, if you keep going northward, how the sky tilts even more, right? And so at somewhere near Arctic Circle or beyond Arctic Circle, this is how the stars will move in sky. Not just stars, but even sun for that matter, right? So this animation shows you a star pattern on in the northern sky, a star pattern exactly on the celestial equator, and another star pattern which is near south celestial pole. So the southern cross or crux, as we call it, Trishanku. Okay, so let me go back to my city's latitude and I'll run this animation again slightly faster. So there you go. If I look northward, see what I see here. This is the Big Dipper or Saptarshi as we know it, and it is going around the North Pole. But yes, it sets and again rises for me, for my city's latitude. But if I go northward, maybe Delhi or even beyond that in high northern latitudes in Europe, maybe. So what do I see? Even from Delhi for that matter. So this, okay, we'll slightly bring it down so that it doesn't go out of our sight. See, now here it has become circumpolar. This Big Dipper pattern, it's not setting, right? So here you can also see the rise and set region or this circumpolar region you can see. So any stars in this circumpolar region, they will never set in your sky. Yes, during daytime you won't be able to see those stars, but those stars will still be there in your sky. So this is called circumpolar region. Similarly, in the southern sky, there will be a never rise or no rise region. So stars in that no rise region will never come above the horizon for you. So many interesting things you can actually learn from here. You can always go back and reset this animation back to its default settings. So this is just one demo. Similarly, we have seasons and the ecliptics, then seasons and the ecliptic, how the sun moves, lunar phase simulator. This configuration simulator is a very good tool to understand the retrograde motion. So I'll quickly demonstrate that. So for example, let's say observer's planet is Earth and the target planet is, let's say, Mars. Okay. So that's blue planet. That's blue is the blue circle is the observer's planet. This one is Mars, the gray circle. And all you have to do is just run the animation. And here you will see the sky view. So there will be sun also, this Mars, and how Mars moves through the zodiac, moves in the zodiac. Okay. Start animation. See, what happens is we started and Mars being slow in its orbit as compared to Earth. See, Earth almost completed one orbit. By the time Mars has completed only half of its orbit. And by the time Earth completes two full orbits, around that time, we are again back to almost the same position or slightly later, around 26 months it takes or 2 months more. So every 26 months, we come closer to each other in our orbital positions. And there is something interesting that happens at this position. Okay, so I'll reset this one and I'll again show you. But this time you don't have to concentrate here in the diagram, but on the zodiac strip. See what happens here. Okay, now see, Mars is going from Pisces to Aries and all the way it has gone to, so it is here. See what happens here. From Aries, Taurus, oh wow, back to Aries and again back to Taurus. So I'll keep it running with slightly more speed and see what happens to Mars every 26 months. See, back and again forward. Again, let's see. Okay, it stopped, back and again forward, right? So that is retrograde motion. So the reason of retrograde motion is only the positions of Earth and Mars. So I'll pause it again and show you. See what's happening here. So for this brief period of time when Earth is about to overtake Mars, from Earth, it looks as if Mars is receding on the star background. But it's not actually the backward motion of Mars. I mean, it is not at all going backwards. It is going its own normal way. Okay, but it feels as if it is going backwards. So I'll slightly slow it down and play it from here. See what's happening. Earth has overtaken Mars, and during this overtaking maneuver, it feels as if Mars is going backward. So this retrograde motion you can understand very well from this one. Not just for Mars, you can try it for farther planets like Jupiter, Saturn, and Uranus, Neptune, and find out what is the difference between the difference among the durations of retrograde. What is the duration of Mars and what is the retrograde duration for Saturn, for example, so that you can learn. Okay. So that was about various demos. So I'll share the link with you later, or I can also share the link to this Google Drive location from where you can download these demos. It requires Flash Player or Content Debugger, as it is called now. I'll include that one also. So that all you have to do is just right click this, go to properties and set that exe as your default player. So you may not find it in the list. You'll have to go to choose an app on your PC and browse to that exe, and you are good to go. So all you have to do is just double click from then after. Okay. Next up, I have a very good website for you. And this is called heavensabove.com. You might be already knowing this. I'm not sure if it's going to run or not, because just a few minutes back I was facing issues with this website. But anyway, since the home page is up, we'll continue. So Heavens Above, there is an app also, Heavens Above app, mobile app, but we'll stick to the website. As you go to the website first, what you do is, okay, I'll just log out from this one and show you. You'll have to sign up first. So since I have already done that, I can go away straight away. I can log in, and then you have to go to change your observation location and other settings. So that's this link, and here you can create your locations of choice. So I have created so many locations from wherever I had to conduct some stargazing event, or I went there for some vacation or trek, or see like Sonmarg, for example. I went for the Kashmir Great Lakes trek, and I uh, saved a location of near our wherever our base camp was. So and so on. So you can save these locations, latitude, longitude, and elevation. You can select those locations on the map also while creating them, and then you can choose from here. So I have chosen Kesriwada. Kesriwada is a very famous place in Pune. This was the birth. This was the place where Lokmanya Tilak lived for a long time, and we have our observatory on the new building terrace in the same campus. So Lokmanya Tilak was also a very good astronomer. He has written very good books on astronomy, and he was also very passionately involved in reforming the Indian calendar. Okay, yeah. So I have set Kesriwada as my location, our observatory location. So here you will see many links. So some links you may want to try are daily prediction for brighter satellites, and the easiest one is this ISS, International Space Station. So it will show you when International Space Station is going to be visible in your sky from your place of choice. So for example, at Kesriwada, or even if I set Kesriwada, it is good for the whole Pune city. I mean, doesn't make a difference. Pune city, for whole Pune city, the numbers are equally good. So 6th of July, this is a link. So I can first just see a few numbers. Smaller the number, greater is the brightness. So this is the magnitude scale. Minus 2.7 is very bright pass. Okay, and start time, highest point, end time, and their altitudes, whether it's visible or not, and so on. So uh, this is from between 2nd and 12th July. These many passes will be visible. So I'll open one of these links, 6th of July pass, and it will show me the sky map of that particular pass. Okay, it's still not responding very fast. So fine, we'll wait for some time, wait for a few seconds, or we will let it load and we will move to our next app. Until now, do you have any questions about whatever we discussed so far?
Vandana sir, the simulations which you have shown, have you created or these are available on online on
No,
the
I
web?
haven't created. Yeah, these are available on the website that I'll share. So you can either download from there, or I'll share my Google Drive location link from where you can download
And
these. Yeah.
is like you are telling a retrograde motion of Mars and other thing. Are they are mapped with the time or they are hypothetical?
I'm not sure I understand the question, but yes,
Can we
these.
can we see the same thing in the sky which is shown in
Yes,
the
yes, absolutely, absolutely. But
okay.
for Mars, you'll have to wait for a long time because, as I said, Mars and Earth come close together every 26 months. So next, I mean, this year itself, in January 2025, Mars and Earth were close together. So of course, the next time will be March of 2027. And just I mean, Mars goes retrograde only for about 2.5 months, 2.5 or 3 months around that time. So it will start showing the retrograde, next retrograde, in around January or February of 2027, and that retrograde will go on until maybe April 2027. Okay, so yes, you can see that on sky, on the stellar background. You can actually see, with the help of background stars, this happening, this retrograde of Mars or Jupiter or Saturn happening. You can actually see it with the help of software and websites. You can in advance know the dates on which Mars is going to start the retrograde and when it's going to end the retrograde and begin its normal journey. Okay. Yes. So this is the sky map for that ISS pass I was talking about, International Space Station pass. So this map you have to hold on your head like this and then align the directions east, west, north, south. So here they haven't put the letters, but you can guess this is southwest and northwest, which means this side is west, this side is east. Okay, left side is east. And here you can see that the pass is going roughly from west or south to northeast. So it always goes from west half of the sky to east half of the sky because that's how it revolves the Earth. That's how almost every space probe is launched westward, or always, always west to east, eastward, because that's how they get benefit of Earth's rotation. That Earth's rotational velocity gets added to it, right? So it will always go from either southwest to northeast on the sky map or northwest to southeast, depending on where it is traveling on your city. Okay, so see, this is how it will start on somewhere around the south horizon. You can see the time also, 7:57 in the evening, around 8 p.m. And every minute there is a timestamp here. And at that time, there will be a moon in sky that's shown over here. And you can see some of the bright stars and that those. So this is Rigel Kent, or this is the nearest star to sun, as we know, Alpha Centauri, Rigel Kent and Hadar. These are good markers. Then this is Crux or Trishanku, the southern cross, which will help you mark the beginning of ISS. And then it will go through this beautiful constellation of Scorpius, and then go ahead, and then this is Altair or Shravan, and then it will descend towards the northeast horizon. So a few more numbers here: rises at what time, reaches 10-degree altitude at what time, and so on. Time, then distance. So we all know that at its nearest, I mean, from Earth's surface, ISS is at around 400 kilometers from us. That's the nearest it can get to us. Uh, so you can make sense of this distance also from that point of view. And then brightness, as it rises, the brightness is very low initially. I'm talking about brightness, okay, not the number. So lower the number, more the brightness. So you can see at highest point or the 24-degree altitude, it is minus 2.7 or around -3 magnitude. That's very, very bright, extremely bright, brighter than Venus. Okay. Yeah. Okay. So this is how you can find out bright satellite passes like International Space Station. Another bright satellite you may want to check is Tiangong. It's a Chinese space station. So that Tiangong link is also there on the homepage. and Hubble Space Telescope. Not very bright, but definitely it is noticeable, or you can spot it when there is a fairly bright pass or fairly high pass in your sky. Okay. Yes. So I think I'll move to the next app if there are no questions. Do we have any questions about whatever we discussed?
Can we see star links also with this app?
Yes, good question, sir. So there is this. So if you go to daily prediction for brighter satellites, so you can see exclude Starlink pass. Can somebody needs to mute Ved Tiwari? I guess I'm getting noise from this. Okay, thank you. Yeah, if you go to daily predictions for brighter satellites, you can see this. By default, it is on, exclude Starlink passes. But if you untake this one, it will show you the Starlink passes also. But it's not always, I mean, Starlink passes are not always very bright. So you have to choose right time, and the sky should be really, really good for you to see that Starlink trail of satellites. But having said that, I am not very happy about Starlink. I mean, no astronomer is very happy, particularly happy about these Starlink satellites, because they are creating more mess for astronomers than, I mean, you may initially see and really wonder about this train of satellites, very, very bright, but it is creating a lot of problems for astrophotography and visual astronomy that people are doing, because these are so bright and they create a lot of nuisance. Okay.
I
Yeah.
just want to know, like
Uh-huh.
when the Hubble telescope passes or the ISS passes, how can we really distinguish that it is such something else that is passing? It's not a star or a planet. It moves. Can we see it moving or something?
Yes, you see it as a bright dot moving pretty fast across the sky. And if you know the path in advance, like I showed you the sky map, the path on the sky map, so you can be confident that uh, the time and place on the sky map, if it matches exactly, then you can be pretty sure that it is either Hubble Space Telescope or ISS, whichever you are tracking at that point of time. Okay. ISS looks very, very bright when it is very high in sky, extremely, extremely bright. So in fact, ISS is the brightest satellite, brightest artificial satellite in Earth's orbit. So as far as Earth satellites are concerned, Moon is the brightest, which is natural satellite, and the next one is ISS, International Space Station, extremely bright. So uh, when you go to this list for your location, always go for passes which are lower than -1. So for example, yeah, -1.6 is good. -0.4, not so good. -3.4, very, very good. -3, very, very good. -1.3 is good. -0.5, -0.4. These passes you can omit. Omit as in initially, just to begin with. Just focus on very, very bright passes first.
Okay, thank you.
You're welcome. Another thing is, not all of these are in the evening sky. Some of these are in the dawn sky or early morning sky. Okay, so that's another motivation for you to get up early if you are looking for one. Okay, any other questions about the apps we discussed?
You said that Starlink is brighter than ISS.
No, Starlink is not very bright. So Starlink, it looks special because it's a train of satellites. Train meaning you can see maybe 12, 13, 15 satellites going back to back. So it moves as a train in sky. So if the sky is good and the satellite brightness is good, then you can see all of them passing just few seconds apart from each other. So yes, it looks exciting, but yeah, that's only a one-time wonder for me, and I don't get pretty excited by that now.
And why there is difference in brightness of ISS at different times?
Basically, this depends on its position in sky. So higher the position in sky, more is the brightness. Okay, so if you remember the earlier, or if you go to, let's go. Let me take you to a fairly dimmer pass. For example, this -0.4, and you will notice yourself that how low that pass is, very close to horizon. So higher it gets in sky, brighter it gets, and this is because of
Size and altitude both.
Yes, size doesn't matter, but mainly altitude is what matters. Altitude from an observer's point of view, right? So uh, if atmosphere were not there, if Earth's atmosphere were not there, then you would have seen it at maximum brightness even at horizon. But it's the atmosphere that plays so many tricks with us. For example, sunsets and sunrises are the moments when we can actually see sun. Uh, Otherwise, when sun gets fairly high in sky, we cannot see. So that's because of the atmosphere. Twinkling of stars is because of the atmosphere. Moon looking yellowish when close to horizon, that is because of the atmosphere. So many effects. When during daytime you can't see anything apart from sun or moon. That is because of the atmosphere. Again, sun is not the culprit. It's the atmosphere that's the culprit. As you already know, you are all many of you are physics teachers, right? So it's the really scattering that we are talking about. So never say it's the sun that causes us not to see anything during the daytime sky. No, sun is not the culprit here. Okay, yeah, it's the atmosphere. Yes, so see this dim pass you can see very low on the horizon. It starts here somewhere on the north, just below the pole star, and then it ends somewhere near east horizon. Hardly, barely it comes above horizon. So you can see the highest altitude is 14 degrees, only 14 degrees. So that's not very high, right? So that's what affects the brightness. So you can see here. So only minus 0.4 at the most, right? So that's not very bright. Okay, so let's go to our next app. This is going to be, I saved the most exciting one for the end, and you are going to love this. If you are not already aware of this, you are definitely going to love this. So I call it the time machine. So this app is called Stellarium. Okay, Stellarium, and you can download it for free from stellarium.org. This is the website, stellarium.org. So you'll see all types of setups. So whichever your machine is, Windows 7, Windows 10, Linux, Mac, and so on. There is a web version also. But for this demo, I'll recommend a desktop version. Okay. So download the setup. It's, I think, around 400 MB, not much, less than 500 MB definitely. And once you install it and launch it, I have made some settings which I'll not go into details right now, but yes, uh, this is simulating the sky as visible from place of your choice. Okay, right now. So you can see here at the bottom right, I have set Earth Pune as my observation location, and 554 meters is the altitude of Pune from mean sea level. Okay, then it shows the date, the time. You can clearly see that it is showing current time. As we progress in time, it is also updating that the positions of the objects in sky. Okay, and I'm going to start from west horizon. So just an important tip, you always start stargazing from west direction when you start in the evening. But why? Because objects on the west horizon, they are going to set very quickly. Some of those objects in 10 minutes, some in 15, or maybe some higher objects maybe in an hour or so. So you don't want to miss those objects. So that's why you always start stargazing from the west direction, which is very easy to identify because you still see some glow, some twilight from the sunset, right? Okay, and this indicates W, it indicates west, southwest, northwest, and so on. And this backdrop, or this foreground rather, this landscape that you see, it is where this app was born, where Stellarium was born. You can, if you think that this tree is blocking your view, then you can change this landscape, and you can horizon option. So I'll do that so that it's good for our learning. So I have set the zero horizon here. So no objects on the horizon to block. Okay, so from Pune, right now the situation is it is raining right now, but doesn't matter. I don't have to do stargazing from the field. I'm very happy, perfectly fine doing stargazing from my Stellarium app right now. Okay, so this is what the situation is on west horizon. We have Cancer constellation, and there is planet Mercury fairly high above horizon. If you click an object, it shows you a lot of useful numbers like azimuth and altitude of the object. See, 15 degrees high on the horizon. Then right ascension declination, those are the fixed addresses of the objects. Then magnitude or the brightness of the object, and so on. A lot of is useful information. Okay, and you when you right click, it goes out. I mean, it is deselected. So if you want to see what is below horizon, just below horizon, so you can go to this. Okay, there is slight lag because there is some loading going on from the internet. I'll just wait for a few seconds. Yeah, good. So on the lower toolbar here, oh, it started loading again. I'll have to disable that for the next time for the demo. Okay, let me check relaunching. Okay, that's gone. Now I'll relaunch it. Oh, okay. Let me set the landscape to 0 horizon. Okay. So if I want to see what lies below the horizon, there is a button where you can turn the horizon off, or you can turn the ground off, and you can see there is sun, and Jupiter is not very far from sun. Sun is currently in the constellation Gemini, the twins. And if you want to see how this constellation looks like, there is this constellation art also that you can enable. So that's Gemini, the twins, Cancer, the crab, Leo, the lion, and so on. Okay. So I'll turn this off for now. I'll bring the ground back on. And if you want to just rewind this picture, you can do that. There is a date time window. So I'll pause the time and I'll rewind it slightly so that I can see sunset happening. Okay, and I want to show you something very interesting. So I'm zooming in and see what happens to sun. So I'll just bring sun very close to horizon, and I'll move in seconds now. What do you see? What happened to the shape of the sun? Anything peculiar?
It's getting oval.
Yeah, exactly. It is getting squished vertically, right? Like a rugby ball or like an egg. So is it a glitch in this software, or it's something actually observable? Yes, this is observable actually. What's happening is, so when these light rays come towards us, they travel through the atmosphere of Earth, right? Closest to the surface, the atmosphere has the highest density, and as we go away from the surface, the density of air goes down, right? So as we go above the horizon, this there is a density there is this gradient of decreasing density, and because of that, what's happening here is bending of rays of light. So as the rays enter from uh, outer space to Earth's atmosphere, they are changing the medium, right? And change in medium causes refraction or bending of light, and it's the bending of light that is making this one squish. So that effect is very high close to the horizon, and low when you travel higher up. So that's what gives this appearance. Okay. Now, if I turn the atmosphere off, what do you think? Are we going to see uh, circular sun or something else? As we said, this effect is due to atmosphere. So if you turn the atmosphere off, that effect should go away, right? And we should see circular sun. Okay, let's see what happens. Drum roll. Oh, wow. sun just vanished. Why? So this is another interesting thing, and it actually is real. So if you turn the atmosphere off, you won't see sun because, as we said, light rays are bent, right? So when you see sun touching the horizon, it is not actually there, but it is below horizon. And from there, the rays get bent, and then the rays travel horizontally through the Earth's atmosphere, and they reach your eyes. So yes, you can see these two interesting, mind-boggling phenomena in this software. With the help of this software program, this app, you can learn these kind of things. Interesting, right? Very interesting. Okay. Now we'll just zoom out a little bit, and we will keep the atmosphere off. And just a few days back, something interesting happened on 21st of June. What do we have on 21st of June every year? The longest day
Okay.
in northern hemisphere, right? Yeah, June solstice. Okay, June solstice. So as you can see, this is true west, and this is where sun is roughly, or I'll adjust the time so that sun is above horizon. Yes. So you can see it is so far away from the west, so far towards the north of the west, right? And that's because you might have heard Uttarayan and Dakshinayan. So this is the northernmost position of sun on the horizon. So we are talking about sunset for this observation. Now what we'll do is we'll just keep on moving the dates. Okay, we'll bring sun a little more up. We'll rewind this picture, and we have turned the atmosphere off so that we don't get this glow. So we don't want this glow around the sun, or we don't want this twilight. So we just are interested in position of the sun, right? Okay, so let's now progress in let's now advance the dates. Okay, 21st of June, from there we'll start and see what happens to the position of sun. Okay, this is the northernmost point we said, right? So now from here onwards up to winter, sun should travel southward. And that's exactly what we are going to see. Okay, 22nd, 23rd, and so on. See what's happening here. So not only it is going uh, towards south, but its position is also changing. If we keep the time constant, its position is changing. And that is because the days are getting shorter, right? So at the same clock time, the sun's position is lower on the horizon, which means sunset is happening earlier and earlier, right? We are at September now. We are very close to this equinox, September equinox. And if we adjust the time slightly, there you go. Do you see sun exactly on the west? So true west rises at true east and sets in true west on equinox days. So that's 21st of March and 23rd of September, March and September equinox. If we keep going, okay, we'll have to adjust the time slightly so that sun is visible for us. We will have to rewind, take this observation slightly earlier at around 5:30 maybe. Yeah. So from September to December, see, it's still going southward. And now we are very close to our December solstice. So 22nd of December. And if I position sun on the horizon, there you can see this is the southernmost position on December solstice. And if you remember earlier, the northernmost position was somewhere here, right? So that is what we saw, Dakshinayan, or southward movement of sun, with the help of this software. And now what I'm going to do is I'm going to fast forward this a little bit, and you tell me what figure you see. Sun, use the page up button for this. Do you see a figure of 8? The video may not be playing very smoothly for you, but do you see sun tracing the figure of 8? Or if I do it slowly, yeah, here you may see it clearly here. Okay, so
Yes.
it's making a loop around that southernmost position now. Then it is going northward. Now it will make an anti-clockwise loop around that north position and going back. So this is figure of 8. This is called analemma, by the way. Analemma, the figure of 8 that sun seems to trace. If you keep tracking sun's position every day at the same time in sky, I mean at the same clock time every day, then it traces a figure of 8. Okay, wow. I'm feeling dizzy. We have gone to the year 2039. Wow, that's too far in future, right? I'm not feeling very comfortable. I want to get home as quickly as possible. So yes, there is a button for that. It says set time to now. So in this area, you will see the name of the button whenever you mouse over it. Yeah, set time to now. Yes, quickly I came back. Okay, so okay, I think somebody has done a markup here. Not sure. Okay, let me see if I can erase those markups. Clear all drawings. Yes. Okay, fine. Okay, so this was, then I will come bring the air also back. So you can do the same. You can select your location. Okay, we'll see a few more options in the software. This is the first window that you may want to see, location window. It has many locations across the world. You can also choose a location on the map directly. Somewhere you can travel to Australia, to South America, to North America or Canada, wherever. Or if you can select it here. Okay, I'll have to reset the location list first. Then let's say Chandigarh, Southern Asia. Yes, there is a place. Or if you want to go to maybe Manali, yes, that's also there. So any place you can select, or you can just straight away enter the latitude and longitude and altitude of the place. That also you can do, right? So plenty to choose from. But interestingly, you can choose the planet also. Planet here means not the planet as in 8 planets, but your uh, body of observation or observer's planet or observer's body, where you want to place yourself to observe the sky. So let's quickly go to uh, one of the moons of Jupiter, maybe, or one of the moons of Saturn, right? And that and see how Jupiter looks like in the sky of that moon. Okay, for example, Io. Okay, yeah, I think we are already there. It has set Io as the observation location. There you go. Wow. From Io, if you are on Io, this is how Jupiter will look like in Io's sky. Okay. And you can also play around in time. See, this is Jupiter eclipsing the sun completely. So total eclipse of, I mean, sun is totally eclipsed by Jupiter, and you'll see this dark void in sky, huge dark void, and nothing else, right? So if you keep advancing the time, Jupiter is back, and there you see the great red spot on Jupiter also. So that's about Jupiter. Same you can do with Saturn also. You can go to one of the moons of Saturn and you can observe Saturn from there. So this has all the planets, asteroids, even some comets or sun for that matter. Sun is also there as a location of choice. So there is plenty to choose from. Okay. And there is a nice button to come back home quickly, return to default location. So it will bring me back to my home city, Pune, very quickly. And this button brings me to the current time. And yes, I am good. So let me show. So already you have seen some constellations, right? So this is a zodiacal. These are the zodiacal constellations. If you want to turn the zodiac on, you can do that also from the markings. You can turn the ecliptic on. Okay, this one. So, we don't want the dates. Okay, I'll turn the dates off. Okay. So this is ecliptic. Ecliptic is nothing but sun's path on the sky map, the path that sun traces on the sky map. And how does sun trace a path on the sky map? So does sun actually move? No. Earth moves. As Earth moves, sun seems to move on the map of stars. So background stars of sun, they keep on changing, and that's what we mean by sun traveling through the zodiac. Okay, So Mars, sorry, Leo, Virgo, Libra, and Scorpius, and so on. So that's how this zodiac is. Okay, and this blue line is the celestial equator. Okay, so yeah, this is the celestial equator, and wherever they cross each other, this path of sun and the celestial equator, there you have equinox. So this point is in the background of sun on one of the equinox days, and you can actually simulate that also. Why not? Keep the time and keep the time same, and if you just advance the dates. Okay, so we know that this is September equinox, so we can keep going towards September. And if we turn the ground and air off, you can keep going towards September, and you will see sun moving to that position on the equinox. Yes, there you go. So you can always select any object and you can center the object. You can zoom in. Okay, and then we will keep on moving the dates. There you go. On 22nd of September this year, this will be the equinox. So sun will be exactly on the equinox, right? Okay. Again, coming back to present time, ground and atmosphere on. Okay, somehow that zero horizon is gone. We'll bring it back. Yes. So here a few more things we'll see, and then we'll take some questions. We would love to see some eclipse, right? So in the recent past, we had two beautiful eclipses from India, solar eclipses. One was around December 2019, and the next one was just 6 months later, around June of 2020. But that was a very harsh time for all of us, June of 2020, because it was pandemic and there was lockdown all around, and people were having a really hard time. So that eclipse we could not really watch from wherever we wanted to be. But yes, this December 2019 eclipse we really enjoyed. So let me bring up that for you. So first of all, let me set the date. So it was 2019 December, around I think it was 22nd December or around that time. So that we can find out even if I don't remember. And it was a daytime, so I'll go to daytime. First, let's see how it looked like from Pune. So I'm I have set morning. I'll select the sun, center it, and then I'll just keep moving the sky. Okay, slightly zoom in. Okay, on 26th it was. So let's see what happens. Okay, maybe. Right. So on 26th of December, and the time is, see, this is the first contact as we call it, around 8 a.m. in Pune. Okay. And you can see this eclipse just starting. And this is going to be partial eclipse, by the way, from Pune. Okay. So it was visible as annular eclipse from South India. So from Coimbatore, but still it looked this beautiful from Pune as well, the partial eclipse. Okay. Now, without changing anything, I can straight away go to Coimbatore from here. I can just go reset the location list and check if I have, yes, there is Coimbatore, Southern Asia. So I'll select that location and I should be able to see a beautiful annular eclipse. Not so soon. I'll have to adjust it slightly, the date and time. Okay, so let's check. So yeah, 9:22, and I'm now traveling in seconds. So there, almost there, almost there. There you go. This is the closest you can get. Yeah.
Beautiful.
So this is how beautiful it looked, and we actually enjoyed this from Coimbatore. JVP team had been there for a conference, and we were the science experts for that conference. So we actually had taken a kit for participants so that they could do some science experiments, and we did some talks around there explaining eclipses and all. So this is how it looked like. It looked really beautiful. Similarly, you can simulate total solar eclipse, lunar eclipse, and so on. And you can actually check how the moon looks red during a total lunar eclipse. And I believe you already know why it looks red. But plenty of phenomena you can, astronomical phenomena can be simulated using this software. Okay. So then let me check my list if I am missing something important. Yeah. So let me come back to the location. Yeah, I'm back to the current time, and let me come back to current location also. There is this return to default location. I'll turn the atmosphere. Yeah, this is already on. Atmosphere and ground is on already. Okay. So anything you would like to simulate, and we can do that exercise here. You can just let me know in last few minutes. We can simulate something of your choice. So this is summer time, so you can see beautiful Milky Way rising at around southeast, pretty early around. Yeah, there you go. So that's the Milky Way patch. Okay, so plenty of beautiful dark, beautiful deep sky objects here in this one. If you want to go check winter sky, you can straight away go to December maybe, and you can see beautiful Andromeda galaxy in sky. So there you go. This is the Great Square of Pegasus, the constellation resembling a horse. Pegasus, the winged horse, as you can see, and the rear legs of or the hind legs of that horse are a different constellation called Andromeda. And in Andromeda, we have this beautiful galaxy, Andromeda galaxy. Okay, so if there is a button of deep sky objects, you can turn that button on, deep sky objects, and straight away you can select Andromeda. We'll turn the art figures off. We'll center Andromeda galaxy, and using a scroll wheel, we can just zoom in. There you go. That's Andromeda and its satellite galaxy for you. And even if it looks very dim or through a telescope, you can only see the core of it, which is very, very bright. The full width of this galaxy is 3 times the full moon, 3 times the full moon's diameter. So full moon is half a degree in sky, whereas this galaxy is 3 degrees, so 6 times the full moon in width. So that's how huge it is, but we can't see the full expanse of it. We can only see the bright core of it. That's why it looks so tiny, even through a telescope. Okay. So plenty of interesting deep sky objects like star clusters, galaxies, nebulae that you can see, and you can turn the deep sky objects off. There are grids like equatorial grid and azimuthal grid. So see, this is the equatorial grid, and if you see the north celestial pole, this Polaris, as we call our pole star, Polaris, pole star, North Star, or Dhruva, as we call it in India. So this is not exactly on the north celestial pole, right? It is slightly off. So even that star, if you move in time, you can see even that star slightly traces a circle. But that is barely noticeable because there is no graph paper in the background, right? So we don't notice with the naked eye this small difference. So another interesting thing is, by chance, just by coincidence, Earth's axis is pointing in this region of the sky where we have this NCP point, but it is not going to always be the same. Slowly, our axis is drifting away from this north celestial pole, and slowly it is going towards Vega. So in 12,000 years from now, that is 14,000 AD, around 14,000 AD, Vega will be our pole star. So if we can always, okay, we'll come back to summer sky so that we can see Vega pretty high in sky. Okay. Yeah, Vega is there. So what I would like to do now is just put it here, put the cursor here, and using page up, I have just pressed the page up button, and we are traveling in leaps and bounds. We are still in the third millennium, but yes, in the 28th century, 29th century, and so on, and see what's happening to this NCP. It is drifting away from this Polaris star. So much, right? It is drifting away. And if we straight away set this to, let's say, 13,500, so you can see Vega is so close to this NCP, North Celestial Pole. So Vega will be our pole star in 12,000 years from now. And similarly, Tuvan was our pole star 5,000 years in past, I mean 3000 BC. That also you can simulate. So this is where Tuvan is. This is the star Tuvan Alpha Draconis. So Earth's axis was pointing somewhere here 5,000 years back. Now it is pointing somewhere here. And in 12,000 years, it is going to point somewhere near Vega. And it will come back to this Tuban. And that's how it traces a circle. This is called precession of the Earth's axis. It's similar to a spinning top. Like a spinning top, axis of a spinning top wobbles, Earth's axis also wobbles. Okay. And that wobbling results in this tracing of axis. And this whole cycle is 26,000 years, 25,800 years. Okay. And if you want to take a shortcut, there is a circle that you can quickly turn on called precession circle. Okay. So let me check. It should be here. Yeah, precession circles. I'll turn these on, and you can see this is how the circle is traced. You can also put the years on it. Few more markings you can put so that you can easily understand. So see, this is 2000, year 2000, 3000, 4000, and so on, 13,000, and then it goes from here to minus 12,000, 11,000, and so on. So this 12,000 is really 14,000, and so on. So really interesting. So many things you can really learn from your desk. I mean, whatever you can imagine, you can actually test it out. You can test your idea in this software. So that's really wonderful. The limit is only the limit of your imagination. There is no other limit. Yes, if you simulate too far forward in future or too far backward in past, then yes, it may not give correct results because this is a mathematical thing. It's based on a model. So don't try to simulate it for maybe 100,000 years or so. But if you play within the range of, let's say, plus minus 5,000 years, it gives you pretty good results, right? So I hope this brief tour of Stellarium and also some of the apps and websites that we saw earlier were a useful introduction to you, were a useful primer to you to begin your stargazing journey. And if you already knew these things, I believe it was a kind of brush up exercise for you. So with this, I would like to end my session. And again, huge thanks to Dr. Hemant sir and IAPT. This NASNI is a very fantastic initiative, I must say. I saw your website and the beautiful photographs that you have uploaded over there. So my best wishes to IAPT and NASNI to carry on with these kind of exciting activities that foster collaboration and also learning on the way. Thank you so much.
Thank you so much, sir. Uh, am I audible?
Yes, you are.
Thank you so much, sir, for such an enriching and engaging session. From practical tools to your thoughtful insights, you have given us a very new and engaging perspective on how we can use these apps and softwares, which can truly open up the skies for amateur astronomers. We are incredibly grateful for your time and your clarity and your enthusiasm that you bring to the science communication. It's been an honor to host you under the NASNI banner, and I'm sure today's session will stay up with all of us for a very long time. Before we wrap up, I would like to take a quick group photo to remember this wonderful session. So I request everyone to please turn on your cameras for a moment. Let's capture this moment together, and then we all can sign off. I request everyone to turn on their cameras, please.
Anjali, all the photos are not coming on the screen. Should I change somewhere?
Yeah, there is a button called View,
Yes, sir. There's
top
a
right.
few options.
You
Okay.
can go to Gallery.
Yes. Please switch on camera. Aluwali sir, Mehta sir.
Yes, sir.
Okay.
Oh, it was a wonderful presentation. I think I missed most of it. I'm sorry. But
That's okay. You can catch up the recording.
yes. In fact, I was trying to pay for Stellarium, but I was not able to pay. I don't know why
It's
that is.
free. It's free, sir. There is a
But the
free
one you
version
are,
on the mobile app also, and even the desktop version that I showed, it's completely free, freely downloadable.
okay. But there is a version, professional version also of that,
Yeah,
isn't it?
that you don't need for introduction. I mean, just to begin
Okay.
with, you can go with the free app. That has plenty of options.
Mm.
Good enough.
But the way you have really taken us through this kind of a journey, I think that's just great, wonderful.
Thank you, sir. My
It
pleasure.
was so nice, and it's really this series is shaping up very nicely, and your presentation is definitely going to be seen by a lot more people. I'm sure about it, because the elements which you have shown to us, I think I was watching that solar eclipse. I remember I gave a radio talk in 1980 when
Wow.
there was a total solar eclipse in the month of February.
Hmm.
That was also seen in the place where I live. I live in Shimla actually.
Okay. Beautiful
So,
place.
and that talk was broadcast during prime time, immediately after morning news in Hindi and English on
Hmm.
All India Radio.
Hmm.
So that was I that part which you showed that reminded me of that whole story, the
Yeah,
whole
I'm
path of that which was being traced in India uh,
right.
in newspapers. It was there was a lot of talk about it.
Yes.
There was no multimedia or anything of that kind at that point of time,
Right.
but there was a lot of excitement.
Yeah, you can always relive your memories by
Yeah, I think
simulating
I
it
was just,
again in Stellarium, this
yeah.
1980 eclipse.
Yes, yes. That is exactly what I was actually thinking, that you are showing it, and then a few physics things also you showed. The
Yeah.
effect of the medium, why we see sun, though it has set above the horizon. Those are
Right.
wonderful observations
Yeah,
which you
I was
really.
thinking many of you are physics teachers, so you might love
Yes,
some of
yes,
these optical phenomena.
yes, yes.
Yeah, and I also am very fortunate to have seen or witnessed this total solar eclipse in 2017 from the US. And that
Oh,
was a mesmerizing experience, really.
mhm,
21st August 2017.
mhm. Yes, yes. So you go to places also to have a look at those things.
Yes, sometimes. Yes.
Mhm. Okay. So this you started this as a hobby quite early, or it was something late which happened?
Something late. Actually, I did not do any stargazing in my childhood or college days. It was quite late when I started working. I just stumbled onto some interesting things like theory of relativity and quantum mechanics and cosmology, and Stephen Hawking's book, Brief
Mhm.
History of Time. And
Yes,
from
yes.
then, it has been a really wonderful journey for me. So this Jyotirvidya Parisanstha came into my life really at the very appropriate time. So
Mhm.
uh, I am very happy to interact with people and to make things interesting for them so that they can learn easily. And
Mm.
at the same time, I keep learning myself through this journey.
Yes, yes, yes. And in fact, in Pune, we have sub RC also of the IAPT. I don't know you whether you know it or not, but I think we will try to connect you with them.
Yes, sure,
Uh,
definitely.
Earlier, Dr. Bharat Kanungude, he was the
Uh-huh.
president.
Okay.
Uh, so you can really engage with them also there.
Yeah, I can see Parimal Dave in the NASNI group. He is a long time JVP member. So in
Okay.
fact, he has spent more years in JVP than I have.
Mm-hmm. And from Pune, maybe you must be knowing, there was one, you know, uh, stargazing atlas which was published by NCERT.
Hmm.
And that was written by Professor Pranjape.
Okay.
You
Yeah,
know?
GR Pranjape
Yes, yes.
or
I have.
Arvind Pranjape.
I'll just tell you because it is lying very near to me. Because ever since NASNI group has started,
Hmm.
I started looking at my books, and
Okay.
I found it. This was actually I purchased this book in 1984.
Oh,
It
okay.
was title was Akash Darshana Atlas. Yeah, it is G.R. Pranjape.
Gora Paranjape. Sir, I'll tell you
Yes.
something interesting. We have the original manuscript of this group, of this book in our office. So
Oh,
he was one of the members, and this book is very, very popular. And there is a free PDF version available of this book, which I can share, but it's in Marathi. So not all of you may be very familiar with Marathi, but yes, the figures and I mean, this is really fascinating to see this kind of book published in such old times.
yes, yes, yes. And the best part, it is I have the English version actually,
Hmm.
and the best part is that it is set in Banaras actually. Everything, the reference is from Banaras itself.
Right, right.
So, and I was just wondering how people do such things with so passion. I mean,
True.
that's a lesson for each one of us,
Absolutely.
that if we have such a great knowledge about the universe and the things around us and the sky, there
Right.
must have been some crazy people around,
Yeah,
and
and they did it in a
spending.
time when there was, I mean, there was a huge scarcity of resources. The books
Yes,
and
yes.
the knowledge was not easy to come by.
Mhm. And there is night sky, there is day sky, both are given there. And you
Yes,
can
yes,
go to one page and it says go there. You will find that it is the same sky which you will see on that particular day in the sky also.
right, Right.
So you are by training engineer, I believe,
Yes, mechanical engineer.
mechanical engineer.
Yeah.
And this is now part of your job, or you are doing it as a
No,
hobby?
this is purely out of passion. So
Okay.
as I discussed or in my introduction, it was mentioned that this organization JVP, it's more than 80 years old now, and very recently, a few weeks back, we celebrated Sahasra Chandra Darshan, which means 1,000 full moons. So that
Oh,
takes 80 years and 10 months.
yeah,
And
yeah.
so in the 81st year, a person celebrates Sahasra Chandra Darshan, but we celebrated it for our organization.
Very
And
good.
in a person's life, it's not always possible that they have seen all those 1,000 moons, but in an organization's history, yes, we can proudly say that we have seen all those 1,000 moons.
Yes, yes, yes. I think we should sit down with you and talk more, like a chat. We should do
Sure,
that.
sure. Yeah, I would love to do more sessions.
Yes, yes, yes. So, Himanji, thank you very much for getting us once again another fascinating hobbyist, I would call, and making us so. I really felt very happy with your presentation. Though I joined late, but the way you were explaining, I started enjoying it. You were taking us on all those ways. You took us to Australia, and you were, in that hemisphere, what is happening and how things are changing here.
Hmm.
That's just great.
Very
So,
happy
on
to hear
behalf of
that. Thank you.
IAPT, I express my heartful gratitude to you. Thank you very much for joining us, and keep coming back. I
Sure.
think
Yeah.
you will
Thank you.
inspire very many people. Thank you. Thank you very
Yeah.
much.
Thank you. It was my pleasure. Thanks a lot for everyone's time.
Any other question from the members? Thank you very much, Sarang, Vandana sir. You have really taken us to open sky through this stellarium, and many things. I am using it for last 10 years, but I have learned so many things in stellarium also.
Thank you.
Now I will request you that some other day we will arrange another talk to discuss about the elongations and other related
Yeah.
things.
So as I discussed with you, I would like to have an
Yeah,
advanced session for this stellarium. Yeah.
new members must know how Venus becomes sometime evening star or morning star,
Right.
and
Right.
how that happens with the motion of the planets in the around the sun and another bodies.
Yes.
So few more things we will learn, but today's session was very engaging and very interesting for me and all the members.
Yes.
And
My pleasure.
uh, thank you very much for sparing time for us. And Anjali, you want to say something and closing?
Sure, sir. I would like to thank Sarang sir once again for this session. It was wonderful. Um, Even personally, I was very intrigued knowing about all these apps and softwares, and I'm sure it has impacted everyone in very good way. And I would like to extend thanks to all the members have attended this session. Thank you. Your presence is what makes NASNI NASNI. And we would love to collaborate with Sarang sir even more. I'm sure this is one of the few initial talks we have,
Sure.
and would love to collaborate with you in future as well, sir.
Yeah.
So
I would
thank
love
you,
it too.
everyone. Thank you, everyone, for your presence. I am Anjali Mishra, and I'm signing off for today's session. Until next time, stay curious and keep looking up. Thank you.
Perfect. Yeah. Thanks,
Thank you.
everyone. Bye. Good
Thank
night.
you. Good night. Good night.
Thank you so much, sir.
Thank you so much, sir.
Thank you. Bye. Good night.
So, thank you, Hemanji. Enjoyed it, really.
Thank you so much, sir, for
What
your
a
encouragement and motivation. Thank
Yes,
you.
sir. I enjoyed it very much, Hemant sir.
Yeah,
Too good.
it
Very,
was very interesting. Yes.
no doubt. We
First.
want him again very soon.
Thank
Yeah,
you.
it was very interesting session, sir.
Yes, yes.
Yeah.
Thank you.
Thank you so much, sir.
Okay, bye then.
Okay, we are signing off. Thank you
Bye.
so
Thank
much.
you.
Thank you.
Thank you, sir. Bye-bye.
Bye-bye. Thank you, Tamanna, for joining, and your students have joined.